I'd like to talk to you today about the idea of a two-sample t-test. I have some data in the calculator for you here, so I'll scroll through it so you can look at it. But basically, list 1 represents the number of tree species that are growing on pieces of land that have never been logged by a lumber company. In other words, no one's ever gone through there and cut down all the trees and then planted new ones to attempt to have them regrow. So you can see these numbers. This 19 means there's 19 varieties of tree growing on that particular plot of land that has never, and this land has never been logged. So in list 2, we have another list of data. These are all the number of tree species that are growing on plots of land where that land has been logged at one point or another. That has been cut down completely and then everything is regrown. All right, so what you have here is you have two different samples. These samples of land plots are coming from two different populations. Populations of land plots where land has never been logged before, and that's what's in list 1, and populations of land plots where land has been logged before, and that's what's in list 2. So what one researcher suspects is that the number of plants, okay, that are in the number of different tree types that are in list 2, on average, would be smaller than on list 1. That somehow there's some long-term damage and the plant species don't regrow all the same way after you've logged over a piece of land. So we need to state our hypotheses. So we're going to do the following. We're going to let mu UL be unlogged. This is the mean number of tree types or species on unlogged land, and then mu log is going to be the mean number of tree types on logged land. So you need to state what these two means are, and then our alternative hypothesis would be, or our hypotheses would be as follows. Usually HO indicates that there's no difference between the groups. So we would say that these two means are equal. Okay, that's one way to write it. Another way to write it, that is probably a little bit better, is probably to write this, that the difference between them, unlogged plots minus logged plots, is equal to 0. Okay, and that's probably a better way to do it. I would probably go with this. It doesn't really matter, though. All right. The alternative hypothesis is what the researcher suspects. The researcher suspects that there'd be more varieties of tree types on unlogged land than on logged land. So the researcher really suspects that this difference, mu unlogged land minus mu land, logged land, would be greater than 0, that this number here in front would be bigger. Okay? And just like with any hypothesis test, you always start by stating your hypotheses, and then you move on to your assumptions. Okay, so assumptions start off kind of the same way. First off, you have to assume that both were SRSs. In other words, that the land plots that were picked to represent the unlogged lands were randomly selected from all the possible unlogged land that could have been chosen from. And then the same thing true for logged lands, that those were also randomly selected. So that's the first assumption. The second assumption is the thing that we always want, and that is that the population of unlogged land plots is less than or is greater than or equal to 10 times the number in our sample. Okay, and then also the population of logged land plots is also greater than 10 times the population. This is the test for independence. Okay, and it's worth to make a note here that S sub x unlogged bar would equal S sub x unlogged over the square root of the number of unlogged plots. And then similarly, the logged, that's S sub x bar of the logged plots would be this expression. Okay, and then lastly, you need to check for normality. So I'll do this kind of quickly, but here's what basically it amounts to. You have to do everything you used to do, but twice. So for example, we've got to make sure that list 1 doesn't have any strong skewness or outliers, and that the normal probability plot is linear. To do that, we do second y equals. We go to stat plot. We go down. We're going to select the fourth type of graph. Here it is. That's called a modified box plot. And we're going to use this on list 1. Okay, and once you've done that, go zoom 9, take a look at that box plot. Doesn't seem any strong skewness. The interquartile range is quite big, but I don't see any outliers. So, I might, depending on what your opinion is, you might say safe to proceed or proceed with caution, but I don't see anything of totally objectionable here where we can't go forward. Okay, and then we'll look at the second type of plot, which is a normal probability plot. We'll select that, again with list 1, zoom 9, and this looks pretty good. It looks fairly linear. Maybe over on the left there, it doesn't look perfect, but I would say that this data probably comes from a normal distribution, and that it's safe to proceed. So now we're going to move on and do that again. So we go to second stat plot, and we go here, except now I'll do the normal probability plot first this time. We're going to do second list 2 and see if does list 2 come from a normal distribution. Zoom 9. Okay, looks fairly linear, maybe a little bit of skewness there. It's not great, but it's sort of like the bare minimum to get by. So I'm going to say proceed with caution in this case. I'd like it to be a straighter graph. And then we'll select the fourth type of graph, and then zoom 9, hope for no outliers. We don't have one. We definitely have some strong skewness. So this was definitely a proceed with caution example. Okay, so you need to copy those graphs down, write down the sentences I just mentioned, and so forth. I skipped it in the interest of time, but you need to do that. Okay. So the next thing is to actually do some computations. Actually, we need to know what is x bar some unlogged land. We need to know the s of x for unlogged land. And we need to make sure we know what n was. And then we're going to do the same thing for the logged land. And what this researcher suspects is that these means down here that I'm looking at, that this mean here is going to be smaller than that mean. That's what the researcher is suspecting. All right, so to do that, we go back to our calculator and go back to what we used to do in Chapter 1. So stat, calculate, one variable statistics of list 1 with no frequency list. Okay, hit enter. So here we are. We got an x bar of 17.5 and a standard deviation of 3.53. So 17.5, 3.53. I'm pretty sure let's just take a look at the n. The n was 12 there. Okay, so now we go and do the same stuff, the same command, stat, calc, one variable stats, but this time for list 2. And here we go, hit enter. And we get an x bar of 13.66. So it is indeed lower, 13.67. Standard deviation of 4.5 and an n of 9. So this is 4.5 and this is 9. So now the magic question is are these two numbers far enough apart for the researcher to have some kind of evidence that logging lands really does inhibit the number of tree types that can grow back? All right, so to do that, we need to find out how many standard deviations away these things are. So let's draw a picture from the mean. So the null hypothesis is that the difference between these two things, unlogged lands and logged lands, is equal to 0. We got an x bar, our x bar of unlogged minus x bar of logged is equal to 17.5 minus 13.67, or about 3.83. So the question is, it's above this, is it far away or not? Well, to do that, we need the standard deviation of x bar unlogged minus x bar logged. And all we need to remember now is from what we learned about random variables, and that is you can't add standard deviations, you can't subtract them, you can only add variances. So this thing's going to equal the square root of this thing, unlogged squared plus s bar logged squared. Or in our case, it's going to be the square root of, and our standard deviation up here was 3.53 divided by the square root of 12. So 3.53 over the square root of 12 squared plus 4.5 over the square root of 9 squared. And that will turn out to be about, I'm getting about 1.81. So now you can tell our standard deviation is 1.81, and our observed difference in the means is 3.83. So it's actually quite a few standard deviations away. it's worth calculating a t-score. So 3.83 minus 0 over 1.81 is about 2.116. So that's pretty far away up here. Here's t equals 2.116. This is the difference in x bars that we got. This is 3.83. And our p-value is this area up here. Okay. So lastly what we do is we need to determine the degrees of freedom so we can look up the p-value. So here's another change. The degrees of freedom in a two-sample t-test is always the minimum of the two sample sizes minus 1. So n unlogged minus 1 and the minimum of n log minus 1. So if we remember correctly, this is 12 minus 1 or 11. This was 9 minus 1 or 8. So the minimum of those two things is 8. So that's our degrees of freedom for this problem. So you know you're going to have to do n minus 1 twice because you have two different samples. You take the smaller of the two. So now we finally finish up by going to degrees of freedom. We go to row 8. We have a t-score. Let's not forget what it was. Where is it? There it is, 2.116. So we're going to take t equals 2.116. And we're going to look across in this table. We're going to go across until we hit two t-scores that bound these things. So I'm finding 1.806 to 2.306. This is, if you look in row 8 and you go across, you'll find these two t-scores. Our t-scores are between them. If you look at the top of that column, you get tail areas of 0.05 and 0.025. So what can we say? We can finish off by saying our p-value, right, is less than 0.05, but greater than 0.025. So either way, that implies that our p-value is less than 0.05, or alpha equals 0.05, which is what we finished. And then we can conclude, what we usually conclude is that we can reject HO in favor of HA, and we can say that there is a significant difference in the number of tree types on unlogged plots of land versus logged plots of land. And we know the direction of the relationship, and it is that the number of tree types on unlogged land is higher than the number of tree types on logged land. Thanks for watching.